We coolin' for the weekend, drop the top and then we out. We do this every season. Sunshades on the sunny days. Doing 80 and we switching lanes. Just keep it cool and chillin' with the babe. Don't call my phone, I hear what you say. Or what you say. We ain't gotta keep this on the low.
Hey guys, what's up? It's your boy Trix. Today I'm going to be doing a Rust video, well, Rust stream, where I found this really cool article that basically walks you through how to build a mobile app with Flutter and Rust. So today we're just going to be doing that. So yeah, let's get right into the video. Sorry, when I switch the scene, you're going to be seeing like triple like whatever in OBS, but I'll switch to the coding virtual desktop so that you don't have to see it for long. Sorry about that. So let me just transition, let me go here. There we go. So Rust wants and share it with Android, iOS and Flutter. A Barcelona-based web and mobile developer wandering through cyberspace, organizer of, currently working at. Oh, that's links. Just so that you know, it looks weird because the original website, if it loads, looks like this, and I'm using Raindrop, which basically just sees that it's an article and just gets me all the information that is necessary. So it cuts out some stuff. I'll link this in the description of the video. Actually, I'll link it in the description of the video now. Hang on, let me put the BRB screen in. And we back. There we are. I just put it in the description of the video just so that if you wanted to and you don't want to watch the whole stream, you can just go to the link in the description to article and it'll walk you through how to do it. Okay, so let's get started. What if I told you that you could use the same very performant code in Android, iOS, or even Flutter? In this article, we'll see how to achieve this with Rust. But why would we want to do something like this? Imagine you have a mobile app that needs to process some audio in order to get some insights about the user, but you don't want the audio to be sent to the server to be processed. You want to preserve the privacy of the user. In this scenario, it would make sense to avoid having to write in a specific library for Android and another for iOS. So I'm assuming this would be like if you want to store the data locally. Having just a shared library would save us from having to maintain 2 different code bases and would diminish the chance to get more bugs. But how could we do this? Enter Rust. Okay, so so far this makes sense, but with the code bases, Dart is its own code base. So if you write Flutter code in Dart, you don't need to maintain 2 code bases. I know that's like a heavy statement to say because there are like some widgets that are specifically for iOS and Android, but you can use platform agnostic widgets. Hang on, I just forgot to plug in the laptop. So if you use platform agnostic widgets, you don't need to worry about ensuring that you're maintaining multiple code bases. But I do also believe there are some platform specific stuff when rendering certain pages, like say for example a single child scroll view. No, not a single child scroll view. Orientation is dependent on the platform that you're writing the code base for, so that might be why this is saying you might need to maintain 2 code bases, but in the majority of scenarios, if you're writing with Flutter, you don't need to have multiple versions of a single piece of code. You only need to have one to compile to both platforms. How could you do this? Enter Rust. With Rust, not only would you be able to share the same code among multiple platforms, but you could also take advantage of the boost of performance they will get by using it. We are going to write a simple shared Rust library and compile it to Android and iOS. As a bonus, we will also write a Flutter plugin using the very same code. As you can see, the scope of this article is quite broad, so we'll try to keep everything organized. You can also read this post while taking a look at the associated GitHub repository. Scaffolding our project. Let's start by creating a folder called Rust for Android, iOS, and create 4 folders in it. Okay, so let me make those folders. So ls cd into docs, ls cd into learning, ls cd into programming. Okay, mkdir Rust for Android -iOS Flutter. Okay, then we are going to mkdir iOS, Android, Rust, and Flutter. There we are. Once we have it, just cd into the Rust folder and create a new Rust library called rustlib. So cargo init -- name rustlib -- there we are. So inside here we now have a Rust library. This library will only have one function that will get a string as its argument and return a new string. Basically just a hello world, but just think of it as a function that could work as the entry point of a more complex process completely written in Rust. Let's install some targets. In order to compile our rustlib library to Android and iOS, we'll need to have some targets installed on our machine. Okay, so let me just copy this. What should be? Why does Rust not work? Linux Rust up. Just gonna wait for this to install. By the way, this website that I'm using is Raindrop. I talked about it in my productivity video. I genuinely recommend it. It's pretty decent. It's like a bookmark manager. So if you don't have like your browsers synced on your phones with your desktop, this just makes it a little bit easier. So like a primary example that I have is I might get sent something at work, right? I don't want to sync my bookmarks at work with my personal machine and my phone, but if I want to share something, like I don't know, I get sent an article at work and I want to look at it outside of work or something because the article is interesting, or I want to make a video on it or something. Using something like this, like a bookmark manager, makes it a lot easier because I don't have to share every single bookmark that I want on each machine and have like personal bookmarks shared to my work machine. I could just share everything inside this app and then just use it wherever I want. And this just makes it a little easier to like manage your bookmarks and like if you want to highlight anything. So like for instance, if I want to highlight this, I just bright and then just literally I just highlight and then just choose what color I want. The only downside is I think on Instapaper or Pocket, you're able to add comments and annotations, but like to do that I need to pay for Pro, and I don't know how much Pro is. Hang on. How much is Pro? I might consider this paying for Pro. But anyway, let me just pull that up again. Let me run Rust up again. To get started, you need to restart your current shell, and this will reload your Flutter. Let me just get back into shell, cd into docs, then learning, then programming, then Rust. Then let me run Rust up. Do I have to source my cat.zich and let me see. Yeah, it did. Don't know why that didn't work. I just sourced my bash profile. I think maybe ZSH didn't refresh. Maybe if I sourced my ZSHRC, it would have worked, but I can't be asked. I'll just do this and then I'll just do the iOS one. I'm not going to touch iOS. For Android, we have to be sure that we have correctly set the Android term, environment, and NDK. Once you get go to Cardo NDK. What's NDK? Interesting. So inside here, let me just drag that somewhere. So customize. Oh, it says a Dracula. That's nice. Plugins, projects. This one. SDK manager. SDK tools. NDK side by side and CMake. So just click apply. That's fine. Just gotta wait for that to go. I didn't realize that this dude is using a Mac. Hopefully everything works fine though. And then we just need cargo NDK. Cargo install cargo NDK. Let me just do that while the other one's running. Yeah, there's no one in chat. It's okay. I was about to say I forgot to have chat open, but I was like, you know what? A bit early. Probably no one's gonna join chat. Cool. Let me just run this again, just check that it works. Yep, that's all done. Cool. And let me close that, let me close this. Okay, so the next step is to modify our cargo.toml just to make sure it looks familiar, similar to this. Okay, so let me grab the cargo.toml. And there we are. Let's just cd into Rust first, and then you guys know I love envim anyway, so cargo.toml. Come on. Rusty the 0.1, that's author, that's fine. There we are. Okay, so let's do lib. Oh, what the hell? Instead of me just copying this out, like writing this out, I'm just gonna copy it. There we go. There we go. Okay, the Xcode stuff I can't do. Now go to the Rust project. Okay. So I'll still do this. It's just I can't get it to compile for iOS because I don't have an iPhone. Well, I have a MacBook, but I'm not going to use it to build for iOS, innit? That's libRC. I mean libRS. There we are. So use std ::f1, but ::ffi : c string. Whoops, not a string. C string. Use std : os : raw : c bar hashtag no underscore mingle pub unsafe extern c function hello 2 : star const c underscore char 2 star mutable c underscore char then just open the function. Then inside the function we grab let c string, so character string equals character string from pointer taking 2, which is just a constant character. Whoops. Then let recipient match that character string to a string, and then use options, use the OK option to match that string, otherwise return an error to match to you. And then inside here we want to get that character string, use the character string library, where we call the new function to make a new character string. We format it inside this string called hello from Rust. Then we instantiate a placeholder and place recipient inside that placeholder. Then we use unwrap and into raw streams. So we unwrap it as a stream and then we convert it to a raw string. And then we have the same thing, no mangle. Then pub unsafe extern c it fn hello release s : star not c bar. Whoops, undo. Oh, so this returns void. Nice. If s dot is underscore null, I want to return. Otherwise, c string from the raw. Whoops. There we go. The no mangle attribute is vital here to avoid the compiler from changing the name of the function. We want the name of the function to be exported as is. Note also that we are using extern C. This tells the compiler that this function will be called from outside Rust and ensures that it's compiled using C calling conventions. You may be wondering why on earth we need this hello release. Let me just check this. Finish. There we go. The hello release function, the key here is to take a look at the hello function. Using C string and returning the raw representation keeps the string in memory and prevents it from being released at the end of the function. If the memory were to be released, the pointer provided back to the caller would now be pointing to empty memory or to something else entirely. In order to avoid a memory leak, because we have now a string that sticks around after the function has finished executing, we have to provide the header release function that takes a pointer to a C string and feeds that memory. It's very important not to forget calling this function from the iOS code if we don't want to get into trouble. If you look closely at this function, you'll notice that it leverages the way memory is managed in Rust by using the function scope in order to free the pointer. This code will be the one that we'll use for our iOS projects. So I can't build the iOS project, but I can still show you like the steps of doing it. So this, yeah, let me just open up a new horizontal terminal. So we're inside Rust already. So cbind gen src lib.rs -l c rusty lib.h. Where we'll be leveraging cbind gen. You need to install it, don't I? Yep. Of course I do. Yeah. There we go. So let me just. There we go. ls. I now have rusty lib. So if I enter this. There we are. So if I scroll down, this is the file we have. Note that cbgen has cbind gen has automatically generated the C interface for us in a very convenient way. Now let's proceed to compile our Rust library so that it can be consumed in any iOS project. Important not to forget the release flag, cargo lipo-release. Okay, so cargo Rust lipo. Oh, do I need to add the iOS targets? That makes a lot of sense. Let's just try this again. Nah. Let me just remove that target then. If I can't use it, I might as well just remove it. V7, so what if I just remove V7? Still I won't make repo run. Never mind, I think it might be a thing to do with, as you can see, I've also installed, why do I never look at anything? I did need to install Lipo. Why wasn't that in the thing for Cargo Lipo? I already had that up. Why wasn't that here? It was, I just didn't read it. I saw this and was like, oh yeah, maybe it's there. Normally when you have install instructions, it should be in a code block. God damn it. Anyway. So I just need to copy those in the roster. So include equals iOS include mkdir include and then cp to include cp toy universal the cool beans. Let's do this then. So just Cargo Lipo release, right? Run on non-Mac OS. That's fine as long as it made it. It made it for AArch and it made it for x86-64, but it didn't make it for universal release. So probably not going to continue with the iOS one? Question mark. Oh no, you should be seeing a tree view like this with included libs. 괜찮아. Okay, so Android, let's create an Android project file. Okay, so inside here, we want to do new project, right? Then basic activity. Next. Okay. Name it Rusty-Android. And set package name. We'll choose. Let me close this actually. Rank 4. Cool. There we go. Just so I don't get confused with the numbers that are popped up. We'll choose Kotlin as our default language. Yep. And as our default language, minimum API to 22. You should end up with a tree view like this. Okay. Where did you Rust for Flutter and then Android? Okay, so let me choose that. Let's go to docs, learning, programming, Rust for Android. Okay. You'll end up with a default tree view like this. So click finish. There we are. So let this just load. This progress bar is just downloading everything that it needs right now. If you remember when we discussed about how to create our iOS project, we need to create a C header working as a bridge, and Android will leave the Java Network Native Interface, or JNI for short, and we'll leverage the Java Native Interface, or JNI for short, and we will expose our functions through it. The way that JNI constructs the name of the functions that will be called follows a specific convention: Java domain, qualified class name, and then method name. In our case, that would be Java.com Roberto if yours, Rusty and one Android. Rusty Android. Rusty-Android. Oh yeah, Rusty Android. Main activity hello. Note that the one represents underscores in qualified class name. Okay. Functions in a specific way. This will cause a problem if you want to reuse the same very code. There's very same code in other Android apps. We'll have several alternatives though. We can use some sort of proxy class that follows the same specific domain and class naming and include it in every project, or we can create an Android library and we use it everywhere. In our case, we're going to create an Android library. So we're going to make an Android library then. So all we're checking is that there's a Gradle. Sorry, I have a thing here. Yeah, it's just building the whole project. It's going to take a while. So if I click File, does it want to work? File, new. Yeah, it's just taking a while. File, new module. Then choose Android library. Then name it Rusty Android-lib. Rusty-Android-lib. Right? Then Kotlin bytecode doesn't matter. Minimum API level 22. Rusty Android lib. Rusty Android lib. Application name. Module name. Mm-hmm. I'll worry about that later. I think it's done, question mark. So Rusty Android lib is here. We have an app, a Rusty Android lib, and then a Gradle folder, right? So inside of this, let me just do project Android. So we have an app, we have Rusty Android lib, src main Java com.example. Yep. Add a little more Rust. Okay, so let's create our Android functions by leveraging the JNI naming conventions. Let's cd into the Rust src folder and create an Android RS file. Okay, so now that I've done that, we're going to get back to Rust. So let me just go back into, no, that's not what I want. Learning programming Rust, cd into Rust. Okay, just type in Rust comment. There we are. And then let's echo, let's go into SSC. Echo android.rs. Why has it done that? Hang on. rm android.rs, right? Touch android.rs. That's a lot easier. That's so weird, man. Once you have it, copy this code into it. If it asks me to copy it, I'm just gonna copy. There we go. Copy. There we go. What's going on here? We better start filming and explain this a little bit. Explain a little bit the previous code. First of all, on top of the file, we can see two different directives: CFG target OS Android and allow non-snake case. The first one will enable this code only when we're compiling for Android, and the second one will allow us to name our functions however we want. Rust enforces snake case, but we need to opt out of this in order to comply with the JNI naming conventions. Okay, but then why have we created two different functions, hello direct and hello? Hello direct and this is hello. Okay. Well, the answer is that I wanted to show you two ways of handling the Android part, and then you decide which one is more convenient for your kind of project. First function uses the JNI crate without incorrect JNI crate. I need to install it, don't I? And the second one uses the same code we have in librs. The difference is clear. The first function is way clearer and more succinct than the second one. Plus, in the second one, we have to deal with the hello release function and unsafe, while in the first we don't. So what should we do? In my opinion, I would use the first one. This is a simple, super simple example where we're just building a string and returning it, and the logic should be also encapsulated in pure Rust library that would be consumed by both iOS and Android code. These pieces of code should be only concerned about providing the glue to the iOS and Android land via C headers and JNI, and that's it. So ideally, in our example, instead of duplicating logic in the Java Rusty lib Android function, we would call another library. Anyway, for the sake of knowing that you have several options, I think it's good to explore all the approaches. One more important thing, note that we're exporting our functions with system instead of C. This is just to stop C bind gen from generating signatures for these Android functions. This won't work. We have exposed our Android model and this to a librs file. Use declarations. Okay. Copy. There. CSG attribute will prevent Android module we just created to be compiled in case we're not targeting Android. Compiling for Android. Let's get ready to compile for code for Android. Create a scripts folder inside the Rust folder and add a file called android build.sh. Whoops. So inside here, I just want to create a folder called scripts, right? And inside scripts, I want to, oh, whoops. Inside here, I want to create a android underscore build.sh. There we are. Then I'm just going to copy all this. There we go. Simply, similar to the previously suggested build script for iOS, this script will help us to compile and move the needed files to our previously created Android library. If you execute the bash script once the compilation process ends, you should be able to find a tree view similar to this one, with a newly created folder called JNI libs with several subfolders. Okay, so I just need to execute this bash script, right? So ls cd into scripts, ls rusty android lib, right? src main. I don't even have a JNI libs folder. What the hell? Cargo install JNI. Cargo install JNI dash 3. No. JNI dash RS. No. Let's see how this goes. Unused return value alloc FFO, and it must be used. Let me end it. SLC librs. Let me go into here. Let me delete that. The easiest thing I can do is probably just grabbing his one on his GitHub repo. It's inside Rust, SRC, Libris. There we are. Let me just grab this. Control C. Let me P. Okay. I'll go build. Yep, same thing. Cool. CD into scripts, and then let me do this. Unrecognized option Android dash platform. Interesting. Mm-hmm. 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 Maybe I copied the Android wrong. Inside the wrong one. SRC Android. Let me grab this. Copy. Let me CD back. Let me enter. Okay. Then what's the actual error I'm getting? Android or Rusty Android, message file alert to. Let me fix each individual one and see what's going on. So in here, let me Control Shift C. So what's wrong with this? Don't know why. Mm-hmm. Can't find NDK. Okay, so I need to. How do I find NDK? Hang on. Cat.zhn. No, it's not in there. Let me go to cat.zhn. I have my Android path somewhere. Where have I put that? Where's Android path? Java options? No. No. Let me just check Flutter Doctor. It says Android Studio is not installed. Interesting. I do have Android Studio installed. To Android NDK. Linux. Where's my Flatpaks? Valid Flatpak. Where's Android Studio? Clone local CD into current. CD into active. CD into Android dash. Oh, that's not a thing. Okay. CD into. I was in bin, so let's try that. What will this do if I run it? Lads, why am I stupid? Ugh. Was it? You just point it to workspace NDK online. PWD. Cool. Could not find any SDK. Set environment Android underscore NDK underscore home. Android NDK home. NDK at NDK version. Okay. Maybe it's because I have this. So let me just. Mm-hmm. Okay. Failed loading manifest, message file or directory. Isage. Mm-hmm. I want to see what the Android, like how they wrote it. So they just done it as ndk.bundle. So they basically removed this end bit. Hmm? Yeah. Android ndk home. Failed loading manifest. Yeah. Why is that being weird? NDK bundle. Yeah. Exit. Let's try this again. But I'm not pointing to that directory anymore. Yeah, it's still calling. It hasn't updated it. I don't know why. Cargo NDK. I don't know why it's being weird. That's very weird. I know it's supposed to look like this, right? But where? Oh, the pain. Hang on. There we are. That's real weird. And by the way, if anybody's like typing in chat, I can't see chat right now. I'm very sorry. Because someone might just be like typing in chat saying, "Oh yeah, do this," and I'm just over here like, can't even see chat right now. Oh no. Nah, it's not working. I don't know why that's not working. But if I... It's there, but it's saying it's using a different one. Android... Okay, Echo. Hmm. Mm-hmm. I have no clue why. That's very interesting though. Because I can't even do anything. Like, I can't move forward because it needs to compile files here. Unless there's something that I need to do inside here. No. Chat got anything to say? Nope. Mm. That was unfortunate because this is a really good tutorial as well. Hmm. Let's see. So what command is it using when it's building for NDK? It's not doing anything, it's just calling NDK directly. So where's NDK? Does NDK build? Should I just use this? Yeah, let's try this. Just using this to store the clipboard. Build learning manifest. Lads, I was executing it in the wrong place. You know when you're just retarded? That's how I feel, man. Why am I so dumb? Obviously, I'm not retarded. It's just something that I say. Sorry. Let me just see the file structure that he's got. He's got Rust, then scripts, then SLC. Okay, so he's got basically the same thing as me. So multiple rlib. Cargo update. Okay, so where did I run it? I think I ran it there. Okay, so Ruslib, the error you've put multiple rlib parameters SLC Android 5.5. Then 6.5. Then 7.5. Has he had any issues closed or something? No, he hasn't. That's interesting. Rusty lib looks fine. Lib devices can't really touch. This one, let me just grab these. Let's see if switching my cargo.toml works. Mm-hmm. Let me try removing that. Cannot create. Okay. Android / Rusty. Android SLC main JNI libs. Android Rusty Android lib. Oh, now I know. How have I cocked it up so much? Hang on. So inside here, inside this Android folder, there's Rusty Android lib. Yeah. So why does this have an extra Android? What? It's lib Rusty lib. Okay, so hang on. Okay, so some things just aren't labeled correctly. Lib Rusty lib. There we go. So that's fine, that's fine. So if I open up Android Studio, now I have main, I have a JNI, libs, and I have everything here. Yeah. We're in the Android library. Finally, we're going to write the Android library and consume it from our Android application. Let's create a new file under Android. Mercy Android lib src main java com whatever this is, Rusty Android lib Rusty kt. So let me have a look at the Android folder. Android Rusty Android lib src main. This one, and you just name the Rusty kt. New Kotlin class file. Let's just name it Rusty. Cool. And then I can just copy paste this. Oh wait, no, I can't. Package whatever. Okay. Then okay. External fun hello. 2 string string. External fun hello direct. 2 string. Right, and then inside here, fun load rusty lib system dot load library rusty lib. There we are. Here we just declared 2 signature mirroring our 2 REST functions, which were these 2. Remember the name we gave them in our REST code and a function that will be called in order to dynamically load the library. Now that we're not using the name of the library, rusty lib rusty-lib.so, but the name that we gave the crate. If you want to generate an AAR file ready to be consumed by an Android app, just use Gradle tab for your Android Studio and look for a task. So there's a Gradle tab. Where's Gradle? Gradle. And then look for a task called assemble. Execute, expand all, collapse all, toggle, build tool settings, task list not built, cancel, touch that, settings, no, Gradle, yeah. That's fine. Let me just whip that there so I can look at the whole thing. Task activation. Gradle assemble command. Find Gradle assemble. Let's see how it is in here. Android. Press the Android lib. Build.gradle. There we are. I was thinking the fuck. Ugh. Just gotta wait for this to finish. How long have I been cooking for? An hour and 30 minutes, goddamn. Cool. Let's try running this again. Build successful, nice. And you'll find it at Rusty Android. Okay, let me exit this. Rusty Android lib. Where is it? I need to switch to project, don't I? Rusty Android libs. Is it in libs? No, it's not in libs. Hang on, let me try finding this. So, this will compile in Rusty Android lib. Yep. Build. output, it's AAR, and it's one of those. That's debug, that's release, so we want release. Cool. So in this case, we don't need to consume the library as an AAR file because we have it in the same project. In case you want to know how to consume it, like that, just look at the Android documentation. In our example, we just need to add the library as a dependency in our Android app build.gradle. So, app build.gradle. Benefits of coding in Flutter. You remember where some things are. Inside dependencies, just need to add this. So let me just whip this at the end. Paste as plain text. And let me just whip that there. Ooh, actually, maybe I want to shift that up. V. Nope. There. And then in underscore choose file sync project by Gradle files. Choose file, then sync project with Gradle files. File. Ah, here we are. I'm dumb. Now open the file. Okay, you know what? Let me just fix this because this is too big. There we are. Now open file that has open file located at Android app src main res, and then which one? Just layout. Layout, and then it wants content main. Cool. And add an ID to text menu. Text view. How do you add an ID? Code. You know what? Let me inspect his code for this one. Android, where is it? Android app src main res layout content main. Now what's he done that I haven't got? Okay, then that's fine, that's fine, that's fine, that's fine. Okay. Oh, okay, so where is my ID? That's fine. ID and ID. Nav host name. Design. Let me see. Add ID to text. How? Android. Okay, so app, src, main, Java, whatever that is, and then Rust underscore Android. Mm-hmm. Let me add this text view. Let me add these two. Build Gradle, plugins, paste as plain text. There we go. File, sync project with Gradle files. Gradle, app, with sync. sync Gradle. Let me do that. Let me do this. Build types. Build features, view binding true. Yep. Okay. So what do I import instead of this? You know what? We're gonna YOLO it. Control C. Let me just whip this. Basic syntax. I have no idea. I don't know Kotlin, guys. I'm sorry. Let's just move to the Flutter one. Yeah, that's fine. Let's just cd into Flutter. Dot. Okay, yes. cd into Flutter. Flutter create template equals plugin /org example rusty flutter lib. Cool. Then let me just grab this copy. Cool. And then rm-rf rusty for libness. Cool. One of the cool things with Flutter plugins is that the templates come with an example project, so you can use it to test out the Flutter plugin works. So like Brett said, no need to create a new project to test out. Our Flutter plugin will basically going to use our previous Android and iOS code and use it in our project. This should be straightforward. Straightforward, yeah. Let me just copy this because apparently this is supposed to work in here. Why does that work? But when I done it, it didn't. Sick. So we have to open the Flutter project. So file, open, Flutter, click over here. This one though. Cool. Then also import the Android library, select file, new. Why new module? Why not import module? File, new. Import module. Android. Why can't I import this module? Let me just let that. Cool. Yeah. No. Why can't I import this module? File, open. I'm going to open the Flutter one. Right? This window. Cool. Then I'm going to file, new, import module. This. Then inside Android, I'm going to grab this. Then build upgrader. Does that work? No. Libs. Build. Output. AR. This one. Okay. Specify location of Gradle or Android project. Okay, so that doesn't work. So what about this? If I select build. Build does not work. Okay, what about if I select this one? That works. And what does he want to import as? Rusty Android lib dash release. Module name. If I click finish, what happens? Rusty Android lib. Yeah. Build.gradle. Yeah. Then SLC main J9 libs. Build outputs AAR. There we go, it's here. Flutter. I don't have an Android phone. Why do I not have an Android folder? Is it because I've done it as a template? Was this made back when templates actually had like Android folders? Hmm. Okay, let me have a look at his. It's a Flutter. There is an example file. I'm wondering then, instead of this, did he make a actual like app? So, okay, I'll try to explain what I mean. So up here, you see where he has template, like this. I'm wondering if this is not necessary. You know what? I'm gonna remake this as a different file. Yeah, I'll remake it. I'm wondering now. Because now my project looks weird. Because if I go into here, he doesn't have... He does... App. Build.gradle. I'm wondering, in his dependencies, does he also have a thing? No. No, 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 no. You know what, it's fine. It's okay. We're just going back a couple of steps. Flutter create rusty flutter lib. Cool. Now let's go back into the Android Studio. Gotta wait for this to load. Let me just do project because it'll be easier. Everything will load. Yeah, now it has an Android folder. I think the plugin thing might have worked before, but now it's different, or he might have just wrote it incorrectly like he did before. But we'll move on. So I need to import the module, new module, then Android library. No, it's import Android library, Android native library, dynamic feature, Java or Kotlin library. No, I'll just import. Yeah, I'll just import it. And then I'll just go into here and then grab this. Right? And then it's just called Rusty Android lib. There we are. There we are. That's fine, as long as it's in here, so cool. Now go into Android app build.gradle. Then inside of dependencies, I need to grab this. Paste as plain text, but not from that, because it's not called release, it's just called Rusty Android-lib. Rusty-Android-lib, so we don't need the release. There we are. Open Flutter Android src main Kotlin, that one, and then Rusty, so there's this one. And then you're here and replace the code with this. So let me just copy this. Control C. import. Where is it? It is Rusty Android-lib. Rusty Android-lib. Let's see. Main, that one. Then inside here is your column, the example. Let's see. Lib. Let's just roll with it. Importing iOS code, CP, Rust, iOS code. Copy the header of the classes folder. Don't open Rust, import sec, don't have it. Don't have that, couldn't API the platform. Open lib, put a lib dot. So lib inside here. See, I'm on the last steps. And I think something's wrong. Like, it's probably because Flutter's updated in the meantime that I'm not able to continue past this. But I'm assuming if I just run the Kotlin part of the application, it'll work fine. So hang on, if the Kotlin part of the application works fine, then I know it's all good. That's fine, and a little bit more Rust, that's fine. What's going on? That's fine. Compiling for Android, Cargo, and DK, that's fine. Writing the Android library, compiling the Android library, consuming the Android library. Okay, so we're done. Run it in your emulator. Okay, so let me open up that project. So that was the Android one. Let me open up this. This window. If this compiles fine, then I know it's okay. Um, we'll just run it on the Pixel 5. Previous. Cancel. We'll just do it on the device that they recommend. So Pixel 2. Let's download it. Just gotta wait a minute. This is going well. Oh, why? So to answer the question of the stream, before you could with Flutter, now don't know because Flutter's framework has changed a lot since. I think this was, when was this made? Is there a date on this? Oh, I can check his GitHub Connect for his last commit. 2019. So what version of Flutter was out in 2019? So for each release, let me just check. In 2019, that would have been Flutter 1. I'm currently on Flutter 3.3, I think. Can actually check. Hang on. Flutter dash 3.5. I need to upgrade. So I'm on the version from July. So yeah, things are gonna break. That makes a lot of sense there. But it is cool that I could have built some of the application inside Flutter. But considering that I now have some of the application built inside Kotlin, that's good enough because it does show that you can use Rust with you can use Rust as the backend alongside Kotlin as your like front end. So the way this currently works with the pieces that do work, right, is you're compiling the application, right? But the actual backend and like functions that you're calling are in Rust, and you're just passing that through to Kotlin to render anything that you want. So any of the like backend code. So you're still using Kotlin to like render widgets and stuff. It's just you're pulling information from Rust. The way it was supposed to work in Flutter is to do the same thing. So you're using Dart to process the information that you're pulling from Rust, and then you're using Flutter to render the actual like content on the screen with widgets. Wait, no, wait, hang on. You're processing data from Rust using Dart, and you're rendering it with Flutter. That's how it works in Flutter. How it's supposed to work in Flutter. With Kotlin, you're processing data with Kotlin from Rust and rendering the widgets with Kotlin. So hopefully we can get it working with Kotlin, and yeah, hopefully we can just get it working with Kotlin so I can say, okay, cool, I've got at least some of it working. This is upgrading Flutter. This is downloading. So while that's going, I'll check out this guy's repos, just seeing what he's been working on currently. What's his most recent ones? He's been working on this Vettel, Figma, Yarn, C#, TypeScript, Rust, microserver, a Node API with Rust, generic block provider, He's got lots of Rust stuff. I wish he had like a readme so you could see what he's working on. Because like if I go to my readme, hang on. On my readme at least, tells you what I'm currently listening to, but the bit that I wanted to see was something like this, where it tells you the current projects he's working on and the current like languages he's using. So as you can see, I've been working on Audio Reader and Exorcism for a long time, and then there's this unknown project. And in terms of languages, I have other Rust, Bash, Markdown, and Toml. The only reason I'm saying I'm coding with my browser is because I have, you know what, I might want to just remove that from here. Remove. Just so it doesn't show the coding with my browser, because I'm not. I don't use my browser to code, I use something else. So if I go to Waka Time is like a monitor for all of the things that you're coding on. Like if you're a developer, it's really good because it gives you like metrics on what you're doing. So here's my dashboard, which just shows me over the last 7 days. Haven't really been coding because I've been doing stuff for work. But yesterday I was working on an unknown project, Exorcism and the Audio Reader. Today I've worked on an unknown project, Rusty Android, Flutter, Rust, and Audio Reader. Then we have, over the last 7 days, I've just been doing coding and I'm browsing for like 6 hours. This just shows like more detailed stuff. In terms of editors, this is skewed because I used to have my browser, I did have my browser there, but I'm using NeoVim most of the time, Android Studio, and Eclipse. Languages, other Rust, Bash, Groovy, Kotlin, Markdown, Toml, XML, Gitmo. Operating systems, Linux. Today, I'm done 45% decrease in what I've been doing, and these are the projects that I've been working on. So if I go to Insights, this just shows, this is like a weekly average, and then my activity, which weekly average. No, I don't want to treat that. Activity, daily average is 53 minutes per day. Top languages are Dart, JavaScript, and YAML, but I don't code in JavaScript. I've never touched JavaScript. My top projects were Monoray, Rapid Reps, and Flutter Developer Test. This one because of my own project, like I spent pretty much a year doing that. Rapid Reps because I spent like 3 months coding that, and Front-End Developer Test probably because that was the... Actually, I don't know why that one's there, because I didn't spend that much time on this one. I spent more time on some other projects. Top operating system was Windows. That's because before I switched to Linux, I primarily used Windows when I was at university. So for a year I was on Windows, then I switched to Linux. And honestly, Linux is a lot better in terms of coding because I'm coding most of the time when I'm on Linux, but setting up stuff is a bit more difficult. Day last year was Thursday, April 7th with 9 hours and 21 minutes of activity. Damn. Projects, these are just all the projects I've worked on. The goals, the only goal I currently have is to code at least 1 hour a week, and today I've done, this week I've done about 4 hours. Share, this is just like different stuff I could put on a repo, and then leaderboards. Obviously I'm nowhere near this, like obviously I'm not nowhere near that, but hopefully gonna get there. If I show you my profile, this is just showing you, oh yeah, cool, this is what I'm currently doing. So NeoVim, Eclipse, or Android Studio, this is just showing you when I've been coding. And languages that I've been doing, operating system, and my website, and that I'm hireable. Obviously I have a job, but if anybody wants to like contract me out over the weekends or something, I'm Gucci for it. And then that's just my total time coding since July 29th of July 2021, 491 hours coding. God damn. How many days is that? 491 divided by 24. So in active time, I've been coding for like 20 days. Fucking hell. That's insane. Nice. And just letting that run. So if I click run. Cool, let's just let that run. I'll put this on my GitHub, and like I'll have like a good readme that just explains like what it is, and I'll reference the original dude as well. Is there a reason it's in this small ass thing? If I like make this massive, what happens? Yeah, cool. I don't really care about this. So app, src, main, no Java, this one, let's run main activity. Doesn't work. Let's take a look. Build. Just chugging, come on. Let's see it happen, come on. For those that don't know, the only reason I don't like using an emulator is because of this very reason, that it takes a long time for it to run. Come on. It's making progress. At least Kotlin outputs more than bloody Flutter does when you're running something. Yes, that's a dig at the Flutter developers. Please add more output to when you're running. I don't want to always run stack trace or something when I'm running an app. I want it to be like this, where it just constantly updates. not just when I click on the screen and it just updates as I'm clicking on the screen. Like, that's not helpful. Of course, I know it's a button click. If I add something to trigger a button click and it outputs to the terminal, of course I want to see it, and that works. But if I'm scrolling or something, I don't need to see the actual like refresh of like the pixels being sent to the console to see, oh yeah, cool, this is happening. Like, come on. I think the developers of Kotlin helped with developing Dart, if I remember correctly. That the actual Flutter UI framework is built by Google, I know that. But for Dart, the type system and everything was based off of Kotlin. And I think IntelliJ helped with like building Dart. Not in like intentionally, or like I don't mean IntelliJ, I mean JetBrains. Because JetBrains built out Kotlin because Android didn't want to build with, what's it called? Android didn't want to build with Java anymore. They wanted to build with an actual like language specifically for Android development. Unresolved 1016. What's wrong with this? Why? I get the weirdest errors every time, man. Hang on, let me check out his GitHub. Nope, that's not it. What am I in right now? Java com example main activity. App SRC. Main. This one. This one. Yeah. Let me check his build.gradle. App build.gradle. Mm-hmm. Mm-hmm. Fuck. Kotlin dash. Okay, so org.jetbrains.kotlin.android. Kotlin Android extensions. Android.extensions. Nope. Pain. Debinding. It says to migrate, but I'm not sure how. Yeah, it's true. And then Android extensions. Let's try that. Nah. Binding.name.text. Oh, so I just add binding before the thing. Okay, so inside here. Hang on. Let's set content and then layout, then fab. So just these three. The toolbar, fab, and view. Toolbar in what's this? This is in view binding. Where's activity main binding from? Cool. Let's test it. I have no idea if this is going to work because I've basically changed it to update to the latest version, and I know that this is like 3 years old. If it doesn't work, then I'm going to call it quits. Yeah. Unknown host. Oh, okay. Adjust Gradle. Finally opens. Double shift 2. Let's go back and just use Stack Overflow. File. Settings. Current and behavior. System settings. HTTP proxy. Auto detect. And press check connection button for Rust. This is the first time I'm ever going to be building something ever in Kotlin. So if this works, heckers. Ah, shit. It immediately closed after running. I think that might be an issue of me updating it, but I have no idea. Because it starts and then immediately quits. What's wrong with it? Access hidden, that's fine, that's fine, that's fine. Okay, let's have a look down here. Common example, Rusty Android unable to store activity component and code activity view inflate exception binary XML file. Yeah, okay, it has to do with me inflating it, so it has no idea what to do because it's trying to access an old version, the old implementation of it from the code, but I've tried to update it to the new implementation and it's not working well. Never mind, that's fine. I'll just turn that off. Anyway, let me just switch to this one. And my face cam died. I had no clue. Sick. Anyway, thanks for watching. Sorry that my face cam isn't working right now. If yeah, if you got any advice on how I can improve this, please leave a comment down below. If you liked the video, please leave a like on the video. If you dislike the video, please leave a dislike on the video and comment down below ways I can improve content on the channel. Other than that, thanks for watching. Enjoy the rest of your day. Subscribe to the channel and peace.
We ain't gotta keep this on the low. Don't do it fast, we can take it slow. Show you things that you ain't seen before. Before you go, you ought to know. I won't be